name is Burr Sutter. My slides are available at bit.ly all your cloud. So all your cloud belong to us. So we're going to be talking a lot about Kubernetes today. We're going to talk about Kubernetes. We're going to talk about how to run it on multiple clouds. We're going to talk about something called Tekton, something called ArgoCD. We're going to show you 3 new open source projects that you probably haven't heard of yet because Red Hat has recently open sourced these things and started talking about them. So one that's involving security, one that involves multi-cluster management, and actually technically 2 that involve multi-cluster management. So we're going to have a lot of interesting things to show you. If the network works for me, we're going to have a lot of demonstrations in addition to the slides and explanation. Now, I have a quick question for everybody here, if you don't mind the show of hands style survey. How many people here are regularly hands-on Kubernetes? You use Kubernetes on a regular basis. Fantastic. So about 40% of you, it looks like. So for those of you who like a hardcore Kubernetes, we'll start with a little introduction, which you might be bored of, but perhaps you haven't seen the what is Kubernetes in a while, so it's kind of awesome to see that from the beginning. But then we're going to go into the more advanced things with Tekton, with Argo, and with some other technologies to show you how to manage Kubernetes at scale. The reason I'm so excited about Kubernetes is because I've been working within the Java community for the last 25 years or so, but I'm really enjoying this concept of Linux containers and how to run Linux containers at scale because it makes infrastructure so much easier to work with. And right now, you'll see that I'm running on 4 different clouds across multiple continents all around the globe. And I was able to set all that up by myself and try it out. So let's get into this. We're going to be moving quickly, so let's do that. So again, 4 different clouds. You can see I actually have data centers I'm running over in New York, Toronto area. I got 2 Ireland, London. I've got Amsterdam and Frankfurt. By the way, my little things here might not be accurately placed. I've got Bangalore, I've got Singapore, and I've got Sydney. So this concept of being able to say, hey, I want infrastructure to run my Java applications, my Go, my Python, my Node.js applications in a declarative way, I think is absolutely amazing. I can decide where I want to put my applications at any given moment, anywhere around the globe, either due to regulatory requirements or due to low latency needs. So if you have a need to be in Asia, it's not hard to be in Asia anymore. If you have a need to be in Europe, you should be in Europe. And I make this point, you notice most of my balls here are in Europe right now, is because I knew I was coming here, and you do notice the latency when you're hopping oceans. So like my New York-based data center will perform more slowly than my London-based data center. And you definitely notice it when you go to Asia, as an example. It actually is much slower. So being close to your customers is very important. It even matters to me when I'm simply just doing demonstrations from my laptop here. Okay? This phrase, by the way, hopefully you guys have heard this phrase before, all your base belong to us. It's a funny internet meme from many eons ago. It was actually a poorly translated video game from Japanese to English. And it actually has a great story. You can go read about it on Wikipedia, but that's where this idea came from. So I love the fact that it has this poorly translated English, but the point is, we master all. We have it all. We take care of everything. And that's what I really love about the Kubernetes ecosystem. Now, I started with Kubernetes back in 2015. You can actually, by the way, again, the slides are all available. So if you go to bit.ly all your cloud, you'll get access to the slide deck right on your phone, right in your laptop. But you can click on the link here and actually watch a video where we launched 1,000 containers live on stage in 2015. This is when the world had not yet heard of Kubernetes. And we were just now giving birth to this idea. And we actually basically launched 1,000 containers. Actually, it was 1,026 live on stage in about 2.5 minutes, and then we let the audience have one. Everybody gets a computer right now. And so you could get on your phone and basically draw a little diagram, and it basically took that image and landed it on a web server running in one of those components. And so ever since that point, I've been kind of enamored by this technology. You know, it took a lot of effort to make that demonstration run, but once you understand how this technology works, the fact you can run it at great scale is kind of amazing, even if it's just a bunch of web applications, a bunch of WordPress applications, a bunch of Java or Node.js applications. So the CNCF, of course, was born shortly thereafter, which basically brought this whole concept of open source, the whole open source ecosystem around Kubernetes to life. And the CNCF, of course, Cloud Native Computing Foundation, has ballooned into this massive ecosystem of technologies. So much like Linux before it, Kubernetes has become a de facto standard when it comes to how you manage many things at scale. And anything that was in that Linux ecosystem before became part of the Kubernetes ecosystem, whether it be storage, networking, security, CI solutions, CD solutions, and we're going to talk about a few of those things in today's presentation. So you're not supposed to be able to read this chart. You can go click on it and go to the link. But it is impossible to read because there's way too many people, way too many organizations, way too many logos involved in the ecosystem. So we're going to focus just on a handful of these today that I want to show you. I want to focus most of my time on, of course, basic Kubernetes and Red Hat OpenShift based on that. But this new thing that you're going to hear about today is Open Cluster Management, another thing called Stackrox. So those are relatively new. And then we're going to talk a little bit about KCP as well. And we're going to spend some time on Tekton and Argo. So we're going to be spending some time with all these technologies. And again, the goal is how do you master all things? How do you actually, basically, all your clouds, all your bases belong to us? Now, you might have seen this chart from me before. I've been using these kinds of sequence diagrams, if you will, for a long time, these evolutionary charts. And I have a whole Bruce Lee-themed presentation today. I've been using that for a couple of years now. But I love this concept of being on the journey. Because all of us here are software professionals, software architects, whether we are working on the actual platform, meaning extending Kubernetes to be more interesting to our development teams, or if we are a Node.js, Java, Python developer, maybe a data scientist, whomever you might be, building applications, we're all on this journey together. And it starts with DevOps, and of course, the concepts of DevOps being cultural change, principles, and some tools. We're going to see some of those tools as we go throughout today's presentation. But DevOps is super critical. Self-service, on-demand infrastructure is super critical. We don't want people waiting any longer when it comes to infrastructure. If you work in an organization today that requires you to file a ticket and wait days to get access to a computer, well, that's a problem. And so I just said that, and some people are just going, what? You wait days for a computer? I can't even conceive of that. And then other people are like, it takes me weeks to get a computer. So it depends on the organization in which you work. If you work for a large, let's say, banking organization, insurance, government organization, in the case of one large insurance company I spoke to, it was over 6 weeks for a developer to get access to a computer. 6 weeks. File a ticket and wait. And the reason that is because their workflow was based on back in the day when you actually bought servers. You know, in other words, we need an RFP process that goes out to the various hardware vendors, basically shops around, get different quotes from those hardware vendors. And let's say Dell wins the quote, they're the cheapest price, get that box ordered, get it shipped to our loading dock, unpack it, stick it in the rack, put power to it, give it an Ethernet connection, power and ping, and then someone load an operating system. That took 6 weeks, and in many cases it takes longer. But in the modern world of the cloud, it shouldn't take that long anymore, right? We should rent these things up in the cloud at an instant's notice. So think about self-service on-demand elastic infrastructure. Think about automation. We're going to talk a lot about CI/CD solutions today in that space. And of course, advanced deployment techniques. That might be where you do your blue-green, your canary, et cetera. That's more like an Istio kind of talk. But we're going to be hitting a lot of these things here in the bottom of this chart. All right? Now, this is a key quote from Bruce Lee. Adapt what is useful, or adopt what is useful, adapt what is useful, and reject what is useless. So you're going to hear a lot of things from me today. Some of it won't apply. Some of it will. You'll have to decide what does apply in your world and what you might be able to adopt and what might be interesting to you. So let's talk about Kubernetes, all right? At a high level, Kubernetes has this architecture. It has this concept of these control plane. Typically, they come in the form of three master nodes, if you manage it all yourself, 3 control plane nodes. And that is because of etcd. Right? etcd needs to be highly available. That is the stateful engine of the Kubernetes component, meaning if you actually say, hey, Kubernetes, do something for me, it writes it to that etcd database, and therefore you need 3 of those. So you got 3 of those, and then you have any number of worker nodes, basically to do the things you want it to do. So Kubernetes cluster is actually relatively straightforward. Typically, you see it in the form of 6, right? So 3 master nodes, 3 control plane nodes, 3 worker nodes as an example. But you can have any number of those things depending on the configuration of the Kubernetes cluster and how you set it up. And it really will depend on your vendor that you're working with. So there's all these different vendors that supply Kubernetes to the market at this point. And they will tell you what the right way to get that set up is, if you will. But often it will look like this. And you basically have various developers and various operations people and DevOps people and platform engineering people and machine learning people and AI/ML people and data science people. It doesn't really matter who the people are, but they basically ask this cluster to do things in a declarative way. Please run my application. You give it that please run my application, and it decides where in the cluster has space and availability and the right resources. Let's say you need a GPU. This machine has a GPU. And it puts your application on the right worker node. So it's relatively straightforward when you think about it, right? It's not actually rocket science. It's basically something that's pretty straightforward. Now, You have to know these different aspects. We saw about 40% of the people here who spend a lot of time working with Kubernetes. So hopefully you're familiar with a pod. The pod, of course, is basically what's running your applications. We'll show you some of those in a second. But think of that as the house, if you will, for your application component. That is your Linux container. They don't call it a Linux container, however, though, because it can have more than one container in it. And you'll see that when we talk about Tekton, or if you actually see Knative or Istio, you will see these multi-container pods really often. We'll see that again in the Tekton demonstration. So it's important to know that a pod can have more than one container. A sidecar container is pretty common, depending on the advanced application. That container basically has a single IP address. That container has a shared single life cycle, meaning it kind of comes up and it goes down. So the pod comes up, the pod goes away, and basically you can think of that as a computer for all intents and purposes. If your Java runs there, your Node.js runs there, your Python runs there. And the good news is, if it runs on Linux, you can pretty much make it work with the Linux container in this context. Now, there's some things that are harder to basically work in this context, right? It might be tricky to get a highly available Oracle database working here, but it can be done, right? It really will depend on the monolithic application that you have and the old style way of how it communicates with its network, its storage system, but networking and storage and all that has been, worked to support those kind of use cases. The older architectures, if you will, are also supporting Kubernetes. There's this concept of the replica set and deployment. We're going to see those in a second, but the idea, that's your declarative desire. I want my app running. 2 of those, please. I want highly available, and 2 of those is what I need, or 3 of those is what I need. And I'd like it to be bound to this particular container image, and I have this liveness probe and readiness probe and some other things like environment variables or perhaps some requests for CPU, core count, or memory. So that's done in a declarative way. So you declare your needs, the cluster takes care of that. There's also the concept of a service, and this is actually probably the key part that makes Kubernetes incredibly powerful. The service that everyone interacts with that has a persistent IP address is separated from the pods themselves. So that means you can do a rolling update very easily. There's also the concept of persistent volumes. The pods have ephemeral storage. If you want persistent storage, like storage that stays there regardless of where the pod runs and how it runs and if it dies and comes and goes, well, the persistent storage is available to you, and then you do everything through labels. So these basic concepts are all you really have to know to kind of get started with Kubernetes and do some really interesting things. Now, there's one other thing I want to mention, and by the way, this is not an intro to Kubernetes presentation. We're just covering the basics right now. We'll show you some basics, but we'll get into the more interesting things in a second. But when it comes to Kubernetes, it has this concept of a custom resource definition. So this was the game changer a few years ago in the Kubernetes ecosystem. Beyond just a basic deployment and a pod and a replica set and a service, now you can extend Kubernetes API with anything you want it to be. If you want it to be beer, pizza, Kafka, no problem. And this is kind of a game changer because now that API is what matters more than the cluster. So you'll have to think about that for a second. We think of Kubernetes as a cluster. It's a cluster manager, cluster orchestrator, container orchestrator, but going forward, it's the API that matters more. In other words, we can separate the API from what's on the other side of that API. And so you'll see that in the project we call KCP. The goal of separating the API from the cluster manager means you can actually then attach it to anything on the other side. It doesn't have to be a Kubernetes cluster. It doesn't have to be a Kubernetes cluster of a certain configuration. They can come in all sorts of different shapes and sizes. And the goal is nothing more than make sure we have access to cores and memory and how to attach networking and storage. Assemble that virtual computer, if you will, that we need to run our applications. So this concept of CRDs is very important and becomes very important when you start learning things like Istio, Knative, Tekton, et cetera. Okay, so let's actually go show you some of these things before we switch to Tekton mode. Again, this is kind of just a recap. I want to make sure we cover some basic ground here. Let's see. If my network stays up, we should be in good shape. So if I say kube control get pods, I don't have any pods right here. I'm in the JSpring namespace, Kubernetes. You'll see that I'm in JSpring here, and I've got a lot of things running on this cluster, okay? Now, this cluster is my OpenShift cluster, which has a lot in it. So if I say kube control get CRDs, right, you'll see there's a lot of custom resource definitions in here. If I go back over to my minikube, kube control get CRDs, I get nothing. If I go to my DigitalOcean, right, kubectl get CRDs, so this is my DigitalOcean cluster. I think this is running in Toronto. You can see there's some that DigitalOcean is running. So here's a key thing to understand when you get your hands on any Kubernetes. what custom resources are available to me? How has it been customized? So that should be question number one once you get beyond the connection to the cluster. So I got connected, now I need to ask it, what are the APIs are available to me? So API resources, and I can basically use that command. And I can see all the different classes, if you will, schema, if you will, that I can apply to this particular cluster. And again, if I'm looking at it from let's say, a OpenShift cluster, it's going to have a lot more because we basically set that up. So OpenShift is set up to be enterprise ready out of the box. So you're going to get a lot more things in that cluster, in addition to the things like Tekton and whatnot we'll talk about in a second. So just keep that in mind when it comes to these custom resource definitions. You've extended the API, and people who've created extensions to Kubernetes have done it this way. So kube control get CRDs is your friend, all right, and kube control API resources, also super critical. That tells you what that cluster can do. Now, there's going to be a different technology we'll tell you about in a second, but it's important that you know that that's how you got those customizations in place. But let's do this real quick. I have a file here, so kube control apply-f, and yeah, my application deployment. So let me go ahead and apply this YAML file. We can open it up real quick. So this is what I mean when I say let's do a declarative. What's your declarative desire for your application? So you can kind of see right here, it's called a deployment. And I would simply say, here, what is my image? Okay, my image, and it's going to pull this one from Docker Hub. It could be from anywhere on the internet, but it's pulling that from Docker Hub. And I have an environment variable. I can have many of those. What port is it going to expose? About how much memory and CPU does it need? And what its liveness and readiness and startup probes might be. Now, this declaration is incredibly powerful. This was a game changer when it came to deployment of applications. If you think about it, the vast majority of applications kind of just would work this way. The liveness probe and readiness probe are super critical also, and you'll see that here in a second. So that's already deploying. Let's go ahead and close that up, come back here. So just by the issuing of this one command, this YAML file, if you remember the chart we saw earlier for Kubernetes, it goes against the API server, it writes the desires to my etcd database, it finds a worker node to run it, and it goes out and runs it. And in this case here, kube control, get pods, wide. I can even see what node it stuck it on. You know, where is it at out there in my cluster? And this particular cluster has a fair number of nodes. You can see I've got a bunch of nodes there. So it could have put it anywhere that it wanted it to, but that's fine. It doesn't bother me where it goes. But this concept of the declaration is incredibly important. Let's actually kind of mess with this a little bit. So edit the deployment, my application, and I want to basically real-time edit. So now I'm actually saying, hey, Kubernetes, go to your etcd database, pull this thing back out again so I can do a real-time edit of it. Now, this is not what you would do in production, but it's kind of fun to do from a development standpoint. So let me change it replicas 3. What else do I want to change here? Let's make this hello instead of what. And yeah, that's good enough for now. We'll leave that. Hit save and close. And you're going to see that it actually starts doing a rolling update. Right? So it's going to roll through, getting 3 of those replicas up and running, and of course, it'll be rolling through there. Let me actually use my little curl command here. We'll curl our way through it. So this application right now is going through a rolling update. You can see it right there. It says, what? Hello? Right? Let's see if every now and then the network will bog down on it, but there we go. So it's just going through that process of saying, basically saying, we took your declaration, you wanted 3 replicas, you wanted this image, you wanted these environment variables, you wanted this configuration, let's redeploy the app that way. And this is incredibly powerful. So if you think about a rolling update, prior to this, it was hard. You might have had a big IP, you know, from F5, those guys, right? You might have had some hardware, some software, some configuration tools. But now it's super easy. Let me go back in here and make another change. Let's make one a little bit more dramatic. I'm going to edit that deployment again. And in the image, let's just actually change the image to Quarkus, let's say. So instead of a Spring Boot application, change it to Quarkus. Same idea. It'll go through its rolling update. So you can see this new one is coming online right now. When that one goes live and ready, then it'll send load its way, it'll load balance it over, and then it'll tear down one of the old ones. And once it has enough of them, new ones running, it'll basically load balance them in place and tear down the old ones. So that concept of basically doing that rolling update, you get for free. It's probably worth the price of admission in Kubernetes alone. This was actually the original demonstration that people showed Kubernetes back in 2015, 2016 that lit the world on fire. Because people are like, what? Rolling updates? You know how hard that is? Now, for those of you who have Java application servers, we kind of knew how to do this already. We knew how to do clustering already. We knew how to do rolling updates already. We knew how to do shared memory, shared storage, because we had that in our WebLogic, our WebSphere, our JBoss Enterprise Application Platform. But for all those Node, C#, Python people, this is a game changer for them, okay? This concept of being able to do something as simple as that with a simple declaration. So I consider that aspect of it to be incredibly powerful. So we're not going to keep messing with this. We could keep messing with it, but let's let it be. Oh, and actually, let's do this. Again, it's fully declarative, right? So if I just say I no longer want that application deployed, instead of making changes to it, I can just rip it all down, okay? So you're going to see it basically, the pods all disappeared up there, and that's all gone. And of course, my little URL thing is going to basically start bouncing off, It's basically going to say, hey, there are no pods. You're missing, all your pods are down, because I just killed it. So that concept, being able to start it up, take it down, that concept of self-service is incredibly powerful. Let's talk about Tekton for a moment, okay? That was your introduction to Kubernetes. So for the 40% of you who already know Kubernetes, hopefully that was a recap. For those of you who are new to it, just remember that concept of declarative desire. I want my app to have these things, make it run. And the cool thing is you can make it run anywhere around the globe, that you can basically find a data center in the cloud. Or if you have a batch of Raspberry Pis over there, you can do it that way too. Now, Tekton also is implemented through custom resource definitions. These CRDs basically define things like pipeline, task. So pipeline and task, pipeline run, task run, those are the most important ones. Now with those, you can declare pipelines. And the cool thing is, unlike a CI engine that you had before, this is using that same exact cluster architecture that Kubernetes provides. In other words, Kubernetes already has the concept of the control plane nodes, whose job is to figure out how to distribute work across the worker nodes, much like we had with Jenkins before, but now it's Kubernetes itself doing this at great scale. So the idea that you can have a pipeline declared is incredibly powerful. So if you think about it from this perspective, the pipeline has tasks, the task has steps. The task is basically a pod, the steps are basically containers running in that pod. And that's really it. So once you understand this concept of API resources and CRDs, the world is open to you. You just say, do I have pipelines? Well, yes, I do. Well, let me use those pipelines in a declarative way. So let's see here. Okay, let's actually go check this out. If I come back here to my cluster here, yeah, we'll let that be. Come here, kube control, get CRDs, grep, pipeline. Okay, you can see I have pipeline resources, pipeline runs, pipelines. That concept, again, I think is incredibly powerful. I just want a pipeline now. If I want a Kafka, I can declare I want a Kafka. If I want a serverless service, I can declare that if I have Knative. If I want a virtualized service to do blue-green canary or really interesting, let's say, dark launches, if you will, within the context of a Kubernetes cluster, that's Istio. And so I can basically declare what I want, and I just have to know about these CRDs. So let's actually try to make this run real quick. Okay, yeah, so we actually, if you watch right here, this is basically looking at pods in this namespace called vote CI. And if I look back over here, okay, these are my pipelines. This is the graphical user interface that we have for OpenShift. But by default, if you're working with regular Kubernetes, you see it this way, right? This is what it normally looks like. So kube control get pods. There's only 2 pods running right now. But I need to basically trigger a pipeline. And so we'll come back to this in a second, but let me just go ahead and make a quick change. Let's go here. Let me just put where JSpring in, hit save. I'm just editing the Python code in this case. And the way you normally trigger a pipeline is you basically git commit. I made it JSpring, and git push. That's how you trigger a pipeline. And then if you catch it just right, let's see here. There we go. See, the pipeline is now executing. And that pipeline, as I said earlier, has these tasks. Tasks are pods. And within each task are steps. Those are containers within the pod. You can see that this one has 2 steps. Okay, and it just finished. So basically, it did the git clone there. That's what it did, git clone. Now it's doing a build and push. And you can see there's 3 of 3 there. So that right there tells you there's 3 containers in that pod that are doing 3 different things. So it's got to do the build, it's got to do a push, and then once it gets completed, and we can see right here, there it is, it's off and running. I can look at it with more detail if I want, and look at specifically all the logs. but it's going through its process now of pushing that change out. So that concept of just being able to monitor how it's all running at scale, as long as you're within the context of a Kubernetes cluster and you need to scale out, you can do that very easily. Now, this concept may not be that important to you if you don't do a lot of CI jobs, but at Red Hat, we have CI jobs that take over 1,000 servers, right? We have really large CI jobs. I've talked to multiple customers during that 1,000 server range for Jenkins. That may sound extreme, but some people who run big pieces of software need a lot of testing, a lot of building, depending on how many commits are getting pushed into the build and how often developers are pushing, et cetera, right? Scale out comes at extreme need. And in this case, with the declaration, as long as you have a big enough Kubernetes cluster, just scales out across wherever you have it set up. So it's going through the process there. We don't have to wait for it, but just think about that for a second. It's as simple as understanding that you have these pipeline resources and these pipeline declarations. We'll come back to that more in a second. All right. Yeah, so it's still going through the process. See, it's doing its push right now of the image. Like I said, we'll talk about that more in just a second. And, oh, by the way, there is this concept of the Tekton hub. So if there are out-of-the-box Tekton tasks that you can have, like, rsync, SSH, send a telegram, trigger a Jenkins job, which is interesting, Jib, Builda, Ansible. So these are the things you can kind of do out of the box, but at the same time, you can build your own. Because the idea with Tekton is it's just like a container image that you create. You can put anything you want in that container image to do whatever it is you need to do. You need to run some specialized C code. As long as it runs on Linux, it'll be fine here. Okay? So just think about that from your perspective, how you would actually take advantage of that. Now let's talk about ArgoCD for a second. If it feels like I'm going rather fast, the goal here was to just cover a lot of ground about interesting things in the Kubernetes ecosystem. So ArgoCD, if you remember that concept of the declaration, right? I basically had a deployment YAML, and I could even live edit that deployment YAML by basically saying, hey, change the image, change the replicas, maybe change my liveness probe and readiness probe, et cetera. That concept of declaration can then be applied to many things. I used it just a moment ago in one cluster, but what if I had many clusters that application needed to run on? What if I wanted to follow the sun, let's say, around the globe, where I want real-time resources, if you will, right here in Europe, because this is when everyone wakes up, and we want applications to have more replicas here. But when it hits 5 o'clock, we start shutting things down and opening them up in the US, or maybe we have to open up in Asia. That concept of having multiple clusters provisioned around the globe and moving applications based on the number of cores that we have and how much load we have, especially if we're thinking about low latency or regulatory requirements, you can now use ArgoCD to manage all that at some scale. It has fewer CRDs, right? It has this thing called application sets compared to Tekton, but it's incredibly powerful in what it can do, right? It allows you to basically deploy across the world. Now, there's a phrase associated with ArgoCD. It's called GitOps. Maybe you've heard that phrase, GitOps. So GitOps, pretty straightforward concept. It's a set of principles, if you will. But you can see GitOps is rising in popularity. Like DevOps before it, GitOps is another term that people are really getting interested in. And it's very simple, right? Everything you create it as an artifact. So in other words, if I am managing a bunch of clusters, I'm not going to build a bunch of bash shell scripts and keep them on my laptop for no one else to see. I'm going to at least check those bash shell scripts into a Git repo and version control them. So therefore, other people have access to them, and other people can see them and review them. That simple concept of putting everything in Git, and then from Git as a source of truth into the actual runtime clusters. So what Argo does is it basically monitors your Git repo, sees that your declarations have changed, figures out the world looks different from declaration in the Git repo to what's happening in live clusters, and syncs them up. But it's just like you saw me do earlier, where I edited the replicas and changed the image. It's essentially the same thing. It's just that it's not a human doing it. It's syncing the live runtime environment to what's in a Git repo. So that's incredibly powerful, right? So Git is a single source of truth. Treat everything as code, and all your operations are through Git-based workflows. You have your audit trail. You know who exactly did what and when. And as a matter of fact, if you don't want any humans touching your production clusters, only these guys, Argo, is touching your production clusters, and you have the source of truth in Git, as an example. Okay? So if you think of a continuous application delivery pipeline, you have your Git source in your source code repository, and so you have both the application source as well as that declarative state resource, meaning that deployment YAML, that service YAML, routes, ingresses, et cetera. And so I might be able to punch all that through a CI engine Tekton is the CI engine you saw earlier. That would, of course, produce an image in an image registry. But then you can update the Git repo for that deployment YAML, and it's basically going to pull that in or push it into your Kubernetes cluster. So Argo works both in a push or pull fashion. So I have a couple of each, right? So one is a pull and one's a push. Doesn't really matter which way you want to go. But its goal is to say, here's my Git repo and the state that's there. Let me sync that up to what we see in the cluster itself. Okay? So ArgoCD is a declarative GitOps continuous delivery tool for Kubernetes. And so you can kind of see right here, it monitors the environment. It basically detects drift. Drift in the form of, did some operations person go in there and modify things by hand? Well, let me just undo those things in some cases. Because what you don't want, right, is the old school way we used to actually set up servers. We used to set up servers, even after we plugged in hardware and put operating systems on them. We actually would get virtual machines, and we would SSH into the virtual machine and yum install this and apt-get install that. Well, you're not supposed to do that anymore. You're supposed to basically have a script for that, right? You don't want users or human operators or human developers touching it. You don't want them building new snowflakes. You want to basically have that update all done in a form of a declarative state, right? I want this image to have these properties. And that's really the goal of ArgoCD, is to make that cluster adhere to what's in the state of a Git repo. Okay? So let's actually try this, a little fancier thing here. A little fancier demonstration while we still have some time. Let's go back over here. So here's one of my ArgoCD examples. Okay? Yeah, so you can see right here, it's basically got 3 things running. So we have 3 different clusters running right here. This is Amsterdam running right here. This is Bangalore, I think, echo kubeconfig. I basically set up different kube configs for everybody, so that's Bangalore. So you can see it'll be a little slow sometimes because it's going around the globe there. What is this one? So that's my New York one, okay? So here I am going from New York, Bangalore, and Amsterdam. You can see right here, this little curl is basically hitting against that application. You can see it says hi, Quarkus, et cetera, et cetera. This number is just an instance variable in the code. This right here is the pod that it's bumping up against. So you'll see the pod there, the pod there. So there's 3 different pods, 3 different clusters, 3 different places around the globe. And again, my Bangalore one's a little slow. If you saw it, it's basically struggling there for a moment. But let's say I want to change the application, the way the application is declared, the way the application is deployed across that infrastructure. Let me go in here. Let's go in here. Okay. And let's do something very simple for now. I'm going to say New York is hello. And let's go to, this is using customized, by the way. You don't have to use it, but you can. It kind of makes things like this kind of fun. So let's go for Bangalore. Let's say namaste. And Amsterdam will say hello. How about that? Okay, so I can even make these things appear different because I want 3 different messages, depending on what part of the world you engage my application in. But by default, the whole goal is simply to change your declarations and push that out around the globe. Git status, I made those 3 changes to those YAML files there. Git commit, new greetings, right? And git push. Okay, now, by default, ArgoCD takes about 3 minutes to realize a change has been made. And if I say app list here, and ArgoCD cluster list, all right? So I have my different clusters there. So there's Amsterdam, Bangalore, and New York. I'm not going to wait on it, though, so we don't have a lot of time. We're not going to wait the 3 minutes out. CD, app list, and then app sync. And then let's do the Bangalore one first. That one's right here, because that one might be a little slower because it is around the globe and has some network changes there. So what you'll see happen here, assuming my network stays up, there it goes. So it's actually up. You can see it rolling update now in Bangalore. And my little curl, is it still working? And so there's namaste, okay? So again, the network isn't performing that great, but it basically did the update there. Let's see here. Let's go ahead and do New York. There we go. There's Bangalore coming along better now. Oh, it's got an error because, again, network issues. But let's see, we got network. All right, there's New York and Amsterdam. So I'm just basically telling Argo to go ahead and sync it. Now, there's also a user interface associated with this, but I'm using the command line in this case. There we go, right here. So I could come over here and just click, sync, or wait the 3 minutes, or change the 3-minute default. Just be aware of that 3-minute thing, because it does catch me every now and then. I'm basically saying, hey, go do an update. And I'm waiting, and I'm waiting, and I'm waiting, and about 3 minutes later, you're like, ooh, there it goes. So just be aware of that. But it's basically detecting that drift and performing that sync. And let's see, did we get this one working yet? There we go. This one's complaining. There we go. And this one was supposed to say hello. There we go. Okay, so again, but based on network issues, my things aren't really updating here properly. But you can see you can roll out changes around the globe, right? And that's the beauty of ArgoCD. It's basically looking at the changes that you've made in your Git repository and syncing those out into real-time objects, real-time resources running in those Kubernetes clusters. Let's show you a more advanced version of this, though. Okay, and let's actually show you the diagram we have here, because this is now this is kind of where these things come together. Okay, so what we have is a little application where we're going to do a git push. That git push, of course, goes to GitHub. The GitHub has a webhook back into our Kubernetes or OpenShift cluster that triggers the Tekton pipeline. That Tekton pipeline does a git clone, right? It says, oh, I got to wake up and run. Let me do a git clone. Let me do my build of the code base. Let me do my build of the container image. Let me push that container image out to a container registry. I'm going to push this one out to Quay.io, which is a Red Hat sponsored container registry, but you can go to Docker.io, GCR.io, it doesn't really matter. And then once that all occurs, the Tekton pipeline also does a quick tweak to the customization file that basically says, oh, there's a new image SHA file out there, meaning just a little tag on it. That means the YAML file is updated. Therefore, Argo, which is watching, goes, whoo, I've had new image. Let me redeploy it. So you can chain all these things together in very creative ways, all depending on what you want. But let's see if we can kind of make this work here. Okay, so let's see here. Let that one be. And in this case here, all right, yeah, let's try this. So you notice the JSpring, that was the change I made earlier. Let's make another change here. So instead of calling this JSpring, I'll just put in my name here. Just say and, because it's basically Python and Go, this application. Get status, git commit, just put in the word and, git push. Okay, so that should kick off. Let's double check, look at our consoles over here. Where'd it go? Here we go. And this one, and this one, and there it is. So that's off and running. But I'll make another change, right? So that was the Python front end. Let's go change the Go-based back end. And one nice thing about this environment is it doesn't matter how you build it, right? As long as it fits an image, you're good to go. So where was this one at here? Okay, I say Go. And I'll just put my name in here, Burr Go. So save, and git status, and git commit. I added my name, git push. All right, so that should also kick off yet the other pipeline. So let's go back over here. And now we have 2 pipelines running. So the API is that Go-based application. You can see it going through its process here. If I go look at the UI one, which was that Python-based one, you can see it's running right here. But the steps are basically the same. Git clone, do whatever is needed for the build, a Go-based build, a Python build, a Java build, doesn't really matter what it is. All right, then take the container image that was created after it's run some tests, push that to the container registry, and then tweak the customization file, which here's an example of what the customization file looks like. And then that will tell ArgoCD to deploy it across the fleet. Okay, deploy it across the fleet. So combining the CI and the CD components here in a declarative way is incredibly powerful. And if we pay attention long enough, we will eventually see this guy getting updated, and this guy, of course, will change based on the curl here. But it does take a few minutes to go through that entire end-to-end process. Let's see, come on. Well, I don't know if we'll get a chance to see it done. You see the JSpring from the change I made earlier. But we'll come back to that in a second. Let me show you one other aspect of this, though, okay? So with Argo, you can update all your different clusters that Argo can see. Cluster list, all right? Or if I look over here, I can kind of see it from a graphical standpoint as well. But what if you want to do things in a different kind of GitOps way? Maybe Argo is not your thing. This is where we've also open sourced a technology called Open Cluster Management. And I'll kind of show you what this does, all right? I'm going to use the GUI side of it as opposed to the where'd it go? Not this one. Okay, this one. Okay, so this is an application. This is my cluster running in Sydney. This is running in Singapore. And where's this one running? This is Frankfurt. Okay, so this is Singapore. This is Sydney. And this is Frankfurt. This is GKE. This is Singapore is which one? I've already forgotten. Singapore is AWS, right? EKS. So Google Amazon, Azure. Frankfurt is Azure. All right, so 3 different clouds, 3 different Kubernetes providers, but basically I'm using this tool right here so I can see them in management scale. This is, again, Open Cluster Management. And then I can look at all the applications that I have, my inventory of applications, right here. You can see I got a bunch of them. And now if I want to make a change, I can go in here into Singapore, and all I have to do is simply say, make it env prod. So the fact that we have a subscription now, same idea as what we saw earlier, it's just that I'm just simply changing a label. And by changing that label, if I look quickly enough, it will basically say, hey, Singapore, which now has this label, and we have all these applications go to any cluster that's marked env prod. Now that Singapore is marked env prod, it's now deploying all my enterprise applications to that cluster. If I take the label away, all those applications are undeployed, right? And it's as simple as adding a label. And so, again, this idea of this declarative way to manage all these clusters, all this infrastructure at scale is incredibly powerful, and it comes from the original idea of Kubernetes. Well, we're almost out of time. So I'll go ahead and update this one as well, env equal prod. Okay, that's my Frankfurt one. Let's go and do Sydney. All I got to do is basically say env equal prod. All right, and the label can be anything you want it to be. It doesn't really matter what it is. So there's Frankfurt. Now you can see Sydney going. Sydney might be a little slower because it's got to go all the way down under because it literally is running in a Sydney data center there, okay? So it's just deploying those applications. So that concept is known as Open Cluster Management, all right? And it's another open source project that's newly open sourced by Red Hat, and you can go kind of play with that yourself, give it a try. The idea is that you have clusters now declared as clusters. In other words, anything that can be a custom resource definition, which is anything, I can make clusters of my clusters. Sounds kind of crazy, I know. But this idea is actually a little bit going a little further. We have another open source technology related to this called KCP. And the idea with KCP is let's extract the Kubernetes API and separate it from the cluster itself. And that means we can now manage all our clusters with a common API that's not tied to a cluster. Same idea you just saw with the previous ideas, except that this actually does one special thing that's very important. The custom resource definition I've been talking about, which is how all this magic happens, those are bound to a cluster at the cluster scope. If you have different development teams doing different things inside their application, they are bound by the same CRD version. And that's always been a major limitation, right? If I use Knative 1.0 and you want Knative 1.1, tough. We're all stuck on 1.0. And that's always been a major limitation. KCP fixes that by basically separating the CRDs and the Kubernetes API from clusters underneath, essentially virtualizing those clusters themselves and allowing you to basically have Knative 1.0 and Knative 2.0 if you want, all within the same cluster. So very important. I would encourage you to go check out this video. Now let me show you one last thing and we'll be officially out of time. And that is security, all right? Related to security. Another thing we've open sourced recently, you might not have heard about it, and it's this thing called Stackrox, an acquisition that Red Hat made a while ago. I'll show it to you in a second. But this concept of security is incredibly important. Here's an example of the website. I actually did a presentation for DevNexus as a keynote back in 2017, so eons ago at this point. But I actually stood on the stage and I talked about the fact that you want to figure out how to use automation to go faster because it's not speed that kills, it's slow that kills. How long are you willing to leave a critical vulnerability in production? Now, for most of us who have large-scale enterprise infrastructure, we leave critical vulnerabilities in production for months, if not years. That's a common practice. It's not a good thing. It just is what it is, all right? I've talked to plenty of people who are stuck in that mode. And so I gave this presentation, and I was talking to a Java audience in the case of DevNexus. I said, you probably don't think about it, but the JVM itself has critical vulnerabilities. And more importantly, libraries you downloaded from Maven Central has critical vulnerabilities. Like, for example, this one in Struts 2, which at that time was February 2017. I said, this is a known vulnerability. It came out a little bit of time ago. Everyone knows how to exploit it, and they can basically use that as a backdoor to steal all your data. And so I told that to the audience in February 2017. September 2017, Equifax comes out and says, by the way, we got nailed by the Struts 2 vulnerability, and we lost 200,000 credit card piece of information. So basically, a whole lot of Americans' data is now on the dark web. And their social security numbers, credit history, et cetera, thanks to this vulnerability. Now that one might not be that exciting to you because it's kind of ancient times, right? Struts, who uses Struts anymore? We don't use Struts. Well, what about this thing called Log4j? all right? You may have run into this one recently, Log4Shell. And so Brian, I don't know if he's here anymore, but he has a nice presentation just from a couple weeks ago. I encourage you to go check it out to talk and demonstrate to you how Log4j can burn you and how with Log4j you can now easily just jump in on that person's server and just take it over. Right? You want to run your Bitcoin miner there? Fine. You want to run, steal all the data? Fine. Okay? So this Stackrox idea, and I'll just show it to you briefly, is to give you access to the cluster. Let's go over here and here. Okay? You can see it has a dashboard. We won't have a lot of time to go through it because it's got a lot of capability, but one thing I do want to show you, if I go in here and you can see I purposely have loaded in a ton of applications that have a lot of problems. You can see I have 1,500 critical vulnerabilities. You can see it stack ranks them by how big of an issue this might be, how much it can be exploited. You can see there's a faster XML JSON data bind issue there. There's all kinds of fun stuff in here, right? So we have the Log4j one issue in here. There we go. There's the Log4j one as an example. But all this is available. Let me go to risk and let me look here. And I can basically see what the CVEs are that could be a problem, like struts, or might be something as simple as how the image was created in terms of, did you actually leave the install tools there or compiler tools there? It also does real-time process discovery. And the beautiful thing about Stackrox is it's a Kubernetes native security tool. So it's not just looking at container images as part of the CI/CD pipeline. It's actually watching the runtime environment and the processes themselves to see if they're being exploited and if there are ports being opened up and stuff being installed when it's supposed to never be installed in an immutable image. And all that's part of the architecture there. And then the other thing it does, it allows you to actually introduce rockctl right into the pipeline itself. So if you've heard the phrase shift left, I want to do these checks during development, if you will. During the Tekton execution, you can see this is an example of one that actually found a ton of issues with just a build. All right, so that's another aspect of it. So we are officially out of time, but I kind of want to mention that as a new open source project that you should definitely check out. Okay? So we talked about open cluster management, something new you probably haven't seen before, manage multiple clusters at scale. We talked about Tekton, we talked about Argo, we talked about Stackrox, we talked about KCP. Hopefully, the whole point of this is you can master all these things at great scale and have a lot of fun with that. So another Bruce Lee quote here, be happy but never satisfied. If you'd like to learn more about these things, we have a ton of free resources. Again, if you have access to the slide deck, you have access to all these links, and you can get out there and go try those. So Tekton is an example, ArgoCD is an example, maybe Istio, Knative, et cetera. And then there's a great book that's also available out there called Kubernetes Patterns. And then another one, if you're interested in microservices and dealing with your monolithic database by Etsy and Naga, one I highly recommend. And then also I have like 6 hours of pre-recorded video where I talk all about the basics of Kubernetes and Istio and Knative. I don't have Tekton and Argo in there because those are relatively new, after I made these recordings. So thank you all so much for your time. I can take questions in the hallway, but I know we are over our time limit. Was this interesting to you folks? All right, very cool. Thank you so much.